Welcome to ScholarMatics. Today we are going to be dealing with trigonometry. What are the values for sine 60, cos 60, tan 60, sine 30 degree, cos 30 degree, and tan 30 degree? So let's go straight into the study. Before we go into the derivation, here are some facts you need to get. This is a right angle triangle with the angle of 90. The longest side, supposedly, is the hypotenuse. So this opposite and the adjacent depends on where the angle is facing. If we have an angle theta here, then this should be the opposite, and this will be the adjacent. This is the hypotenuse. If we have an angle theta here, this would be the opposite, the side opposite the angle, and this would be the side adjacent the angle. So these are some of the facts you have to get. And also, sine theta is equals opposite over hypotenuse. Cos theta is equals adjacent over hypotenuse. And tan theta is equals opposite over adjacent sides. So if you should get these facts correctly, the derivatives of these special angles is going to be very easy. So the summary of these values is that sine theta is opposite of hypotenuse, cos theta is equals to adjacent over hypotenuse, tan theta is equals opposite over adjacent. So that can be written in short form. We have so ka tua. So for you to remember quickly, this can be a tip. So ka tua. Sine is equals to opposite over hypotenuse, cos is equals to adjacent over hypotenuse, tan theta is equals to opposite over adjacent. Okay, so now let's pick a triangle with an angle of 60 degrees. That would be an equilateral triangle. An equilateral triangle has equal angles and equal sides. Let's say this is an equilateral triangle. Let me make it bigger. This is an equilateral triangle. Don't mind my drawing. So here we have 60 degrees. Here we have 60 degrees. Here we have 60 degrees. So these three sides of the equilateral triangle also have equal length. So let's pick 10. Let's pick 10. Let's pick 10. Actually, to make it very easy, we can pick 2 instead of 10, since we are going to have the same answer no matter the values we use. So we could say 2 to make our work faster and easier. So here, if we should divide this equilateral triangle into 2, we pick 1/2. It becomes a right angle triangle with length of 2. Here it becomes 1, 1. So we have 1 here. Here is the angle here is divided into 2. So we have 30 degrees. And here we have 60 degrees. But we don't have the length of this side. So the first thing we're going to do is to look for x, the missing length. And how do we get x? Don't forget your trigonometric ratios. S. Don't forget your trigonometric values. S, so, Ka, Tua. So here we have the hypotenuse. This can either be our opposite or adjacent because we have two angles here. And this can also be our adjacent or opposite since we have two angles here. So to look for x, since we have the other two sides, we can just use the Pythagoras theorem that doesn't need or require angles. So according to the Pythagoras theorem, hypotenuse square is equal to opposite square plus the square of the adjacent side. So our hypotenuse side here is 2. 2 square is equals our opposite side here can either be 1 or x. So let's pick 1 square plus then our missing side, that's x square. So solving this, 2 square is 4 because the 1 square is 1 plus x square. So x square is equals to 4 minus 1. Then x square is equal to 3. So x is equal to the root of 3. So our missing side is 3. So in the right angle triangle, we have 2, 1, and root 3. $30. 60 degrees. So Ka, Tua. So let's begin our derivatives. Sine 60. What is sine 60? Since sine here is equal to opposite of hypotenuse, our opposite side is what? Since we are considering 60 angle 60 degree, so this is our opposite side. It is opposite to the angle of 60 degree. So sine 60 degrees opposite root 3 over our hypotenuse is 2. So root 3 over 2. So that is the value for sine 60, the angle, the special angle sine 60. What about cos 60? Cos 60 degrees will be equal to adjacent over hypotenuse. So our adjacent side, since we are considering angle 60, would be 1 over, then our hypotenuse would be 2. What about tan 60? Tan 60 would be opposite over adjacent. Since we are considering angle 60, our opposite side is root 3 and our adjacent side is 1. So tan 60 is root 3. So the same thing also applies to angle 30. So sine 30 degree would be opposite of our hypotenuse. Opposite of our hypotenuse. So the opposite here is 1. And the hypotenuse is 2. Cos 30 degree. Cos 30 degree would be adjacent of our hypotenuse. So the adjacent is root 3. And the hypotenuse is 2. Then our tan 30. Then our tan 30 degree would be equal to opposite of our adjacent. So our opposite is 1 over root 3. So these are the derivative of the 60 degree and the 30 degree.